Labguy here. Good morning. It's February 9th, 2021, or what we old folks used to call the future. Okay, today we're starting part 1 of the NBTV DissectorCam project video series. So work has begun on that. If you've been following the update videos, which I really hate bringing to you, because really when I publish an update, it means I don't have any progress to show. So enough of that. Let's get some business out of the way. Welcome all new subscribers. Thank you for subscribing. I appreciate your subscription. I appreciate your viewership, and I appreciate you. Thank you for watching my videos, and hopefully I'll continue to bring you interesting information, even if my production values aren't on par with a lot of other channels. So having gotten that out of the way, the DissectorCam project. It will be based on the IT&T FW130 image dissector tube. I'm guessing the era of this tube is somewhere between 1968 and 1972. This is a very late generation tube. The steerable photomultiplier tube. This is the actual tube. It has some information. Each of these tubes was semi-custom in their day, and some of the information would be printed on it. This one has a 0.014 inch or 14 mil aperture. It's printed on here, so we know that. For this size of a photo sensor, that works out to about 40 lines of resolution. As I speculated in the last video, I believe these are for guiding heat-seeking missiles or laser tracking missiles. I don't know that for a fact. Based on the construction, this thing's built like a Coca-Cola or a Pepsi bottle. It's very thick, it's very robust. This is a commercially made photomultiplier tube base made by that company, and it contains all of the voltage dividing resistors and is custom made for this tube. And when I bought this tube, it was also inside of a cryogenically refrigeratable chamber, stainless steel chamber, which I have no use for and no specifications for its electrical needs. It uses thermoelectric coolers and a water jacket, so I don't really want to get into plumbing. So anyways, so I got this nifty base. You supply it with 1000 volts DC, and it will output the video signal generated by the photomultiplier tube in the form of a microscopic current, which I know how to deal with photomultiplier tubes. You can see this tube has a lot of pins. It has a lot of multipliers. I believe there's 11 multipliers in here. So at any rate, to make this into a television camera, moving right along, it's going to require me to build a housing around this that comes out to here, will support the deflection coils, which go on the imaging section. This is the imaging section. This is the multiplier section. Here's a deflection coil from an XY video monitor. Unfortunately, they're a different diameter, but we'll deal with that. Currently, I use a small adapter that I made that keeps the yoke from rattling around. The final enclosure will actually support the yoke itself, and that won't be necessary. So we need to support the yoke, cover the tube and block light, and cover up some of these exposed high voltage contacts, which would cause poor old Labguy a bad day if he was to touch them. And if they're there, I'll touch them. I just can't. I can't help myself. Okay, I'm smarter than that. Shh, don't spread it around. Okay, so here we are. This is the requirements I have. So I bought the new 3D printer, which you can hear in the background if you're astute, and am preparing to produce the components for the enclosure. Here's my drawing, which I colored with some colored pencils. I'll give you a nice close-up of that. The orange part is the lower housing, or as I call it, element A, and element B, segment A, segment B. Segment B has been printed, and segment A is on the printer as I speak. If you look closely, you'll see that the barrel section of the multiplier housing has a parallel sides to this point, and then it's a truncated cone. I'm learning to use Design Spark 3D, which is a drafting program, and I was successful at producing this cylinder with this angle, which was 11.03 degrees. That's burned into my mind. And this is a round cylinder. We're looking at it as a cutaway. And I was able to measure with my calipers, measure the device, and produce this very nice cross-sectional diagram, which I then entered into Design Spark and produced this image, which I then sent to the to Cura, the slicer. Which produced a file for the printer, and I was able to print this. I know it's not much to look at, but it is section A. There is a conical section, and I printed it in a filament called Black as Night on purpose because it needs to block the light getting to the tube. It covers all of this lower section and fits perfectly with no play. It fits onto the Bakelite cylinder perfectly. Protects me safely from the high voltage, and is the support base for the second half, which is, like I said, currently printing. Last evening I began printing that part, and it's printing upside down like this and has a ledge here for supporting the deflection coil. But what I've discovered is that I measured this and I made that hole not large enough, and so the yoke won't go in. So a second try is being printed, and the slicer says that it's going to take 13 hours, and I just started it less than an hour ago. So that is currently being printed and will constitute the second half of the enclosure, and it looks like this on the drawing, and this is facing downward. The front of the tube is at the bottom, and the pocket here is where the deflection coil will sit. and it actually, relative to the tube, sits like this, but is printed like this, and has a ring up here which will fit nicely inside of here, so that the two parts will make together and block the light. So as of this moment, that is the current status of the NBTV DissectorCam project, which will ultimately produce a 32 line by 12.5 frame per second video signal for mechanical televisions and for my cathode ray televisor, which uses a CRT, and should produce live images. That's the goal, and it's probably going to be some time. But before we can get too far into it, I have to build the physical support structures for the camera tube. After segment B, then I have to produce a segment C, which mates to the front of that and has the proper back distance for the lens to be in focus on the photoconductor, and that's how those elements will go. Ultimately, when all three elements are perfected, I'm building this in multiple parts so that I can fix each section as I go. When they're all correct, we will then go back into Design Spark and mate the three pieces together into a single element and spend 24 to 36 hours printing that. And it will be about 200 millimeters high. It will go from the base up to above the top of the tube, and be a solid black cylinder, because I'm basing my camera's appearance approximately on this picture. Very early Farnsworth camera, and so it's going to resemble that, not perfectly, but it will resemble that in appearance, and that's the design goal. So thank you for watching today's video. Once again, welcome all new subscribers. Being that this is YouTube, I'm not going to say it because everybody else says it, but you know what to do. I know that my viewers aren't stupid. So, if you liked the video, you liked the video. If you didn't like the video, you didn't like the video. That's all right. If there's some complaint you have, please leave a comment and let us know what it is. We'll try to fix it. And if you want to say something nice, that's welcome as well. So until next time, Labguy out.